All right, so underground mining, as we discussed or as we discussed earlier on, that we have method of extraction or method of taking our mineral of interest from the earth crust. We have done the surface mining systems or extracting our mineral of interest using surface methods. And then we also have using underground mining methods. So today we are going to look at how we can extract our mineral of interest using the underground mining method. In mining, a method of extraction which will yield the largest net profit is preferable. So if you are practicing mining, you always select a method of which that method will help you to gain the highest amount of money or the largest profits. So if you are a mine manager or if you are working in a mines, and then let's say you are, in the future, you are asked to join a mine planning team or any other team, let's say exploration team, if you are supposed to select a particular method for mining, there are two things that you have to look. If you are selecting a method for mining, there are two things that you have to use, especially when you are selecting an underground mining method. The first you are supposed to look at is safety, because underground can be a little bit dangerous. Should anything happen underground, I'm not sure. You could deploy 100 people underground, and then there is an issue underground which leads to, let's say, a rock fall or a part of the underground failing. In fact, we might lose more than 60% of the total number of people who are underground working. So if you are designing any underground mine, you take safety into consideration. The first thing you're supposed to look at is this method safe? Can we use this method? Now, the next thing you have to look at it is money. Are we going to incur cost? What is the cost involved in this method? If we are to use this method, are we going to get the highest profits we are looking for, or we are going to run at a loss? If you do all this analysis and then you get to know that, fine, my method is safe, we can mine it under a safe condition, and then we can mine and then we get the highest amount of money, then you can go ahead and then select that particular mining method. All right. So the mining method choosing must be safe and must ensure optimum extraction under the particular geological condition encountered. I think as I was explaining, I said all these things. You have to make sure that the method you are selecting, one, it's fulfill these two conditions. It is safe. You can't deploy people to an area which the area is not safe. So there is a saying which is common in mines that if it is not safe, don't do it. That is what happens when you are starting the mine. You choose a method which is safe. You look at these things and then you take into consideration that is this method safe for me? If it is not safe, then I have to choose a different method. Now, after looking at it being safe, you look at the optimum extraction. So this method that I'm choosing, am I going to get the highest profits? If I'm not going to get the highest profits, I choose a different one. Now, the best method of stooping depends on certain factors. When we talk about stooping, I explained when we are doing the terminologies. The stooping is an area of which ore has been taken or drawn from. If there is a particular, now we don't use stooping in surface. It is, if you do, the moment you hear stooping, it means you're going to underground. So this word is going to be predominant in my explanation. We're going to hear stooping. The moment you hear stooping, it means that's an excavation of which ore has been drawn from. So we don't have stopes in surface mining, but we have stopes in underground mining. So we are looking at the conditions that helps us to, or that allows a particular method to be a good stope, or how we classify stopes. So we are saying that the best method of stope depends on the geological characteristics that determine the span of the back or walls of the stope. That will be self-supporting during removal of ore. Now, if you look at this thing that I just said, you saw some terminologies here. You saw back and then walls. The moment you hear back, the back or the walls, it's just that if you are in underground mining, you just raise up your head and then you see rocks around. So if you are selecting the stope method, you have to make sure that The geological characteristics that determine, it is the geological characteristics that determine the span of the back or the walls of the stoop that will be self-supporting during ore removal. When you're removing ore, the stoop is supposed to be able to stand without failing. Any quantity stoop able. So the stoop in bit match a wall no ho. Wall no nkyerɛ surface mining wall na you can, but you see when you create space between something, you see at side and side, right? The side and side is what we're talking the wall, or we can even say the roof or the wall, the back. The back is when you raise up your head, what you see up there is what you call the back. The back or the roof should not be loose. If it is loose, it means that materials can remove upwards and then come and hit on machineries and then people who are working in the stoop. So therefore, if you are selecting a stooping, you have to take into consideration the geological features of the place. Look at the rock type, the competency of the rock. Is the rock strong enough? Is the ore itself, is it strong enough? If it is strong enough, it tells you what the method you're supposed to go for. If it is not strong enough, it also tells you maybe you just need to adjust your system and then add underground support to the whole stoop, and then that will help. The second point is that the nature and you have to also take into consideration the nature and size of the support required. Now, after doing this, looking at the geological characteristics, maybe you get to know that, okay, fine. My country rock is not all that strong. It is moderate. Therefore, I will need a support system. Now, what is the type of support you're going to use? In underground, we have a lot of materials we use to say supporting our roofs and then the whole underground mine. Am I supposed to use timber? Am I supposed to use some part of my waste to support? Am I supposed to use split sets? Am I supposed to use gears? They are all support systems that we used. So you look at the nature, what type of support do I need to make my underground stand without failing? You have to look at all these things. And then the next one is the availability and the type of support required for permanent openings to avoid subsidence or caving. Now, when we talk about subsidence, that is when it fails, that is subsidence or caving. Sometimes we can intentionally, mining engineers, sometimes we intentionally leave a place for it to cave in. But then if it is not in the plan, that is a serious issue, and then it's a safety concern. So the third point is trying to let us understand that we should know the availability of the type of support. This type of support, is it common? Will I get it? It's not that I'll start today, I have my support system there. I will mine to the second level. Support. I'm not getting the material for the support. If you are doing this, it means that the second level, it is going to fail. So if you are selecting a support system, you have to know that the support systems are, or select the support system that are readily available, that if you need some, you just stretch out your hand and then you get it. If the support system is very scarce, please don't go for it. So if you look at those practicing the galamsey, their support system, they use stick. So galamsey for no they just go and then take the and they take it underground and they use for their support systems. This requires a good knowledge of the geology of the area so that permanent openings may be placed in solid, stable rock. So starting a whole underground mining system or practicing underground mining system, your geology must be very good. You should know the type of rocks you are going to mine. So if you are taking this, or if you are linking this to the stages of mine life, it means that your exploration data should be very, very, very accurate. So therefore, before we start an underground mine, it involves a whole lot of things. We have to plan. We have to make a lot of tests, test the rock, take samples to affirm that this is the strength of the rock. Now, if you know the geology of the area, if you know the rocks that you are going to mine, you know that, oh, this side of the rock is very hard, this side is not what? Hard. Rocks are not homogeneous, they are homogeneous. It means that the properties of the rocks are not the same. From this point to this point can be very hard, the other point to the other point can be very soft or can be very weak. So if you see that this particular section is very hard, you can put your permanent openings there. Permanent openings like the main entry, your ramp, your decline. You can put your decline there because the decline is the main access. That is where everything that is entering underground. So wherever you're putting your decline, the plate should be the rocks there should be very strong and competent. The rocks there should be very, very strong and competent. If they are not strong and competent, you cannot put it there. Correct application of mining methods may be established. Okay, stopes may be planned for optimum stability and ground control. So if you look at all these things, it's talking about safety, 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 safety. Yes, and because underground, if we don't take care, if you joke with your safety, you are going to kill a lot of people there. Overall mining systems may be planned. Yes, cost of maintaining the mine openings may be minimum. Maximum safety to be achieved. So the last thing there is maximum safety.